Let's go to our first question today. Refer to the exhibit. Which statement about the configuration setting is true? Okay, you can see this image, the SSL VPN configuration page image, and you can see the port 1 IP address is 10.200.1.1/24. Okay, let's go to the question number 2. An administrator has configured a strict RPF checks on FortiGate. That means strict reverse path forwarding. How does strict reverse path forwarding check work? Okay, let's go to the next question. Refer to the exhibit showing a debug flow output. What two conclusions can you make from the debug flow output? What two conclusions can you make from the debug flow output? Choose two. Okay, let's go to the next question. What are two benefits of flow-based inspection and compared to the proxy-based inspection? Choose two. Okay, let's go to our next question. Refer to the exhibit. The exhibit shows a diagram of the FortiGate device connected to the network. Okay, the firewall policy and the virtual IP configuration on the FortiGate device and the routing table on the ISP router. Okay, we can see the firewall policy and the VIP configuration of the FortiGate device in the exhibit and the ISP router routing table. When the administrator try to access web server using public address 203.0.113.2 from the internet, the connection times out. At the same time, the administrator run on sniffer on FortiGate to capture incoming web traffic to server and does not see any output. Okay. The problem is when administrator try to access web server from the public side, the given public IP address from the internet, the connection is not working. At the same time, the network administrator try to run sniffer on the FortiGate to capture the incoming web traffic, but it cannot capture due to an error. Hello everyone, welcome to 591 Lab. Today we are discussing few sample questions about FortiGate Security Professional, FortiGate Administrator, version 7.4. Okay, before moving to the questions, let me explain about 591 Lab. We are the top IT training and certification exam brand in China, Hong Kong, Taiwan and Singapore. Our mission at 591 Lab is to provide our client with the exceptional exam preparation experience for certification in Cisco, Huawei, Aruba, Juniper, Palo Alto and Fortinet exam tracks. Okay, before moving to the questions, let's check our agenda today. Today we discussing about SSL VPN and RPF called reverse path forwarding and debug flow output, firewall inspection mode, proxy mode and flow mode, VIP called virtual IP and CTNA, Zero Trust Network Access. Okay, let's go to our first question today. Refer to the exhibit. Which statement about the configuration setting is true? Okay, you can see this image, the SSL VPN configuration page image, and you can see the port 1 IP address is 10.200.1.1/24. Okay, let's check the answer A. When a remote user access http://10.200.1.1:443, the SSL VPN login page opens. Answer B. When a remote user access https://10.200.1.1:443, the SSL VPN login page opens. The answer A and B different is first one HTTP, Second one HTTPS. Okay, answer C. When a remote user access https://10.200.11:443, the FortiGate login page opens. Answer D. The settings are invalid. The administrator settings and the SSL VPN settings cannot use the same port. Okay, let's find out the correct answer. Okay, first log into the FortiGate and come to VPN section. Under VPN section, you can see here SSL VPN settings. Okay, now the listen on interface is not added, so I am adding one interface. You can see here listen on port 443. This is the default port for SSL VPN listen on interface, and you can see here the web mode access will be listen at https://10.200.1.1:443. In here you need to understand that the both GUI and SSL VPN default port is 443. In the interface you can see the interface IP address is 10.200.1.1. In the menu comes to the system settings, under the system setting the GUI port also 443. That means default port is 443. Then you need to understand the default port 443 assigned to FortiGate GUI access and the SSL VPN configuration. So both use same ports. Okay, when you check the question exhibit, it's also asking about the default port. It means 443 ports. Okay, let's navigate to FortiGate 7.4 Administrator Study Guide, page number 278. You can see here SSL VPN settings. The FortiGate interface for SSL VPN portal and the default port is 443. By default, the admin GUI interface and the SSL VPN portal use the same HTTPS port. Advised to use different interface for admin GUI access and SSL VPN portal. Okay, now the question is asking using default port. If both services use the same interfaces and the port, only the SSL VPN portal appears. That means the priority goes to SSL VPN portal page, not the FortiGate GUI. Okay, let's go back to the question and find out the correct answer. Answer A. When a remote user access http://10.200.1.1:443, the SSL VPN login page opens. That seems correct, but it's HTTP, not HTTPS. Then answer A is incorrect. Let's go to the answer B. When the remote user access https, the SSL VPN login page open. Okay, answer B we can select as a correct answer. Let's go back to the answer C. When a remote user access https://10.200.1.1:443, the FortiGate login page opens. As you can see here, we already saw that the priority goes to SSL VPN login page, not the FortiGate. So answer C incorrect. Answer D. The settings are invalid. The administrator setting and the SSL VPN setting cannot use the same port. No, we can use same port, but priority goes to the SSL VPN login page. So we can select answer B as a correct answer. Okay, let's go to the question number 2. An administrator has configured strict RPF checks on FortiGate. That means strict reverse path forwarding. How does strict reverse path forwarding check work? Okay, let's check the answers. Strict RPF allows packet back to source with all active routes. Answer B. Strict RPF checks the best route back to the source using the incoming interface. Answer C. Strict RPF checks only for the existence of the last one active route back to the source using incoming interface. Answer D. Strict RPF checks is run on the first send and reply packet of any new session. Okay, first let's understand what is reverse path forwarding. The reverse path forwarding check is a mechanism that protects FortiGate and your network from IP spoofing attacks by checking for return path to the source in the routing table. By looking at the diagram, you can understand this. Assume that the FortiGate doesn't have route back to packet source address through the incoming interface. Then the source address of the packet was routed incorrectly. In this case, you want to drop that unexpected packets. And there are two types of RPF. That means two types available for reverse path forwarding. First one is feasible path, normally you know as a loose mode, and the second one is strict mode. In this question asking about strict mode. Okay, let's understand what is strict mode in reverse path forwarding. In this mode, FortiGate also verifies that the matching route is best route in the routing table. For further understanding, point number 1, when the packet arrives at the FortiGate firewall, the device checks the source IP address. Then come to the routing table lookup. The firewall lookups the routing table to find the best path to reach the source IP address. Then interface match option. The firewall compares the interface through which the packet arrives with the interface that would be used to reach to the source IP address. That means the source IP address and source packet incoming interface also need to match to find out the best route. Then traffic, FortiGate take decision to drop or pass the traffic. If the interface match, the packet is considered valid and forward. If they do not match, the packet is dropped. Okay, strict RPF follows three major points. That means it's check the source IP address, then find out the best route, then check the traffic incoming interface, then select the traffic pass or drop action. Okay, let's go back to the FortiGate and understand how to configure reverse path forwarding. When you log into the FortiGate, you have to go to CLI for enable RPF. Open CLI console, then type config system settings, then set strict source check. You can see here disable and enable. Default mode is disable. You can enable it like this. Okay, let's open FortiGate 7.4 Administrator Study Guide, page number 86. You can see here all the details related to reverse path forwarding. It is mentioned that the reverse path forwarding checks mechanism that protect FortiGate and your network from IP spoofing attacks by checking for return path to the source in the routing table. And there are, you can see there are two RPF checks modes. First one feasible path, second one strict. The strict mode, FortiGate also verifies that the matching route is the best route in the routing table. If the routing table contains matching route for the source address and incoming interface, but there is a better route for the source address through the another interface, then RPF check fails. Hope you can now understand what is the strict reverse path forwarding. It also check the best routing table, best route, then check the incoming interface, and then check the source IP, then forward the traffic. If no matching, the reverse path check fails. Okay, let's go back to the question and find out the correct answer. Answer A, strict RPF allow packet back to the source with all active routes. No, we haven't learned this. It's not all active routes, hence answer A is incorrect. Answer B, strict RPF checks the best route back to the source using incoming interface. As you can see, we check best route and the source and incoming interface. There are three criteria need to be matched. So B we can select as a correct answer. Let's check the answer C. Strict RPF checks only for the existence of at least one active route back to the source using incoming interface. It's not active routes, hence answer C also incorrect. Let's check the answer D. Strict RPF check is run on the first send by reply packet of any new session. No, this one also incorrect. So the question we can select answer B as a correct answer. Okay, let's go to the next question. Refer to the exhibit showing a debug flow output. What two conclusions can you make from the debug flow output? What two conclusions can you make from the debug flow output? Choose two. You have to select two answers. Answer A, the debug flow is for ICMP traffic. Answer B, the default route is required to receive a reply. Answer C, a new traffic session was created. Answer D, a firewall policy allowed the connection. Okay. Before find out the correct answer, let's understand this debug flow output. Okay, let's log into the FortiGate with the sample lab setup and understand debug output and how to enable debug output. Now you can see a simple lab setup, one firewall and Windows PC connected to the firewall. The Windows machine IP address is 10.200.1.10 and the firewall interface is 10.200.1.1 and firewall have one WAN connection which is internet connection. Okay, let's log into this firewall and enable debug output flow and monitor the traffic. Okay, as per the lab setup, the source IP address is 10.200.1.10 and the destination IP I putting Google DNS IP 8.8.8.8. Okay, now I am enabling debug output. Okay, let's initiate the traffic from the Windows machine. Now you can see the IP address is 10.200.1.10. Now I am initiating ping to Google DNS 8.8.8.8. Okay, now you can see here the debug output generated when the traffic initiates from the source IP to destination IP 8.8.8.8. You can see in the first line, received packet protocol 1, the source IP 10.201.10, source port 512, and the destination IP 8.8.8.8. Okay, we need to understand what is this protocol 1. When you go to the image of the question, you can see here it's also mentioned protocol 1. Okay, now you can see in the FortiGate document library protocol number details. The protocol number 1 is ICMP traffic, Internet Control Message Protocol. You can see here all the protocol numbers listed. The protocol 17 means UDP. So we can understand that the traffic is ICMP traffic because the protocol is equal to 1. And when you look at the debug output on the question, you can see here that the new session allocate a new session. Okay, let's open FortiGate 7.4 Administrator Study Guide, page number 450, Debug Flow Example. You can see here the highlighted explanation. Here, IP address, port numbers and incoming interface details. Allocate new session means create new sessions. Find a route mean found a route, matching route. Source to next hop IP address, outgoing interface. You can study further details using FortiGate 7.4 Administrator Guide about debug output flows. Okay, let's go back to the question and find out the correct answers. First answer is the debug flow is for ICMP traffic. Yes, this is correct because of the protocol equal to 1. That means ICMP traffic. Answer B, the default route is required to receive a reply. No, this one is incorrect. Answer D, a new traffic session was created. Yes, this one is correct because you can see here allocate a new session. Message is displayed in the debug output. Let's check the answer D. A firewall policy allowed the connection. No, this answer we cannot select as a correct answer. We can select answer A and C as a correct answer. Okay, let's go to the next question. What are two benefits of flow-based inspection and compared to the proxy-based inspection? Choose two. The answers are: answer A, FortiGate uses fewer resources. Answer B, FortiGate performs a more exhaustive inspection on traffic. Answer C, FortiGate adds less latency to traffic. Answer D, FortiGate allocates 2 sessions per connection. Okay, first let's understand what is flow-based inspection and proxy-based inspection. Okay, you can look at the firewall policy which I have opened in the FortiGate firewall. You can see here inspection mode. The default selection is flow-based and you can change it to proxy-based mode. And also when you configure security profile like antivirus, when you create antivirus profile, you can see here feature set that is also available, flow based and proxy based. The default mode is always flow based. Okay, let's understand what is flow based first. The flow based inspection inspect packet as they flow through the firewall without stopping them. It analyzes traffic in real time and generally faster because it's process packet on fly, suitable for high throughput environment. In the resource usage, use fewer resources, CPU and memory. And it's provide balance between performance and security but might not catch all the threats. So it's ideal for environment when speed and performance are critical, like large network with the high traffic volumes. When you look at the proxy-based inspection, act as an intermediately like proxy for client and server communication. It terminates the connection and re-establish the connection to the destination. Talking about the speed, slower compared to flow-based inspection because it involves more detailed analysis and re-establish connection. Hope you can understand. The resource usage use more resources, and that means CPU and memory, because it handle inspect entire sessions. The security feature is provide deeper inspection and higher security, capable of detecting more threats. It is capable and ideal for environment like security is priority, such as handling sensitive data or where detailed traffic analysis is needed. You can apply proxy-based inspection mode in the firewall policy. As a summary, we can say that flow-based inspection fast, use fewer resources, suitable for higher traffic scenarios, offers good security. In the proxy-based inspection, more secure and use more resources. It is suitable for environment need detailed inspection, and it is slow compared to the flow-based inspection. The choosing between two depends on your network performance and needs and security requirement. Okay, let's go to the FortiGate 7.4 Administrator Study Guide, page number 47. You can see here inspection mode on firewall policies. You can see here enabling the security profile on the FortiGate, inspect on firewall resources and throughput. Packets are sent to the kernel or main CPU to enforce filtering. FortiOS support flow-based and proxy-based inspection in firewall policies and security profile. As you have seen this, you can enable proxy-based and flow-based in the security profile as well as an security firewall rule. Depending on your requirement, you can select inspection mode, but it is useful to know some different and how it can impact the firewall performance. For flow-based inspection identifies and blocks threat in real time, as FortiOS identifies them, typically require low processing resources than proxy-based inspection. It is recommended to apply flow-based inspection to policies that prioritize traffic throughput. Okay, more detail you can read from the FortiGate 7.4 Administrator Guide, page number 47. Let's go back to the question and find out the correct answer. The question is asking two benefits of flow-based inspection compared to proxy-based inspection. So you have to answer flow-based inspection benefits. The answer A, FortiGate use fewer resources. Yes, you know that compared to the proxy-based, flow-based is a default mode. It is use fewer resources. The answer is correct. Answer B, FortiGate perform more exhaustive inspection on traffic. No, this one is incorrect. Answer C, FortiGate adds less latency to traffic. Yes, this one also correct. Answer D, FortiGate allocate 2 sessions per connection. No, this one is incorrect. For this question we can select Answer A. FortiGate use fewer resources. Answer C. FortiGate adds less latency to the traffic. Benefits for flow-based inspection. Okay, let's go to our next question. Refer to the exhibit. The exhibit shows a diagram of the FortiGate device connected to the network. Okay, the firewall policy and the virtual IP configuration on the FortiGate device and the routing table on the ISP router. Okay, we can see the firewall policy and the VIP configuration of the FortiGate device in the exhibit and the ISP router routing table. When the administrator try to access web server using public address 203.0.113.2 from the internet, the connection times out. At the same time, the administrator run on sniffer on FortiGate to capture incoming web traffic to server and does not see any output. Okay. The problem is when administrator try to access web server from the public side, the given public IP address from the internet, the connection is not working. At the same time, the network administrator try to run sniffer on the FortiGate to capture the incoming web traffic, but it cannot capture due to an error. Let's read the answers. We have to find out the correct answer. Answer A. Configure a loopback interface with address 203.0.113.2/32. Okay, answer B. In the VIP configuration, enable ARP reply. Answer C. Enable port forwarding on the server to map external service port on the external service port. Answer D. In the firewall policy configuration, enable match VIP. Okay, let's find out the correct answer. Okay, let's go to the sample lab setup and understand the question clearly. In this setup, you can see here there is a Windows machine 10.200.1.10. In the middle, you can see the FortiGate firewall. The firewall interface to the LAN side is 10.200.1.1. And the external side, I have connected another PC to demonstrate the issue. The PC IP address is 172.16.1.10. The interface is 172.16.1.1. The traffic which I have initiated from this 172.16.1.10 PC to 10.200.1.10 PC using virtual IP, that's mean destination net. Let's log into the FortiGate and create firewall policy for the allow traffic between VPC to Windows machine. Let's name the rule as a DNet. The traffic incoming interface is port 3 because its IP address is 172.16.1.1. The outgoing interface should be our LAN side 10.200.1.1. That means port 3 to port 2. Source at the moment I am put as all. The destination side you have to configure DNet. So DNet will create DNet from here, virtual IP server. You need to add name. Then external IP should be external map interface IP, whatever you configuration. At the moment the external IP is 172.16.1.1. The map IP should be the Windows machine 10.200.1.10. Okay, I have added this destination net to the rule. Service I am putting as all services should be net disable, and all session I am allow the firewall policy. First we'll disable the firewall rule, then come to VPC, try to initiate traffic to the 172.16.1.1, the interface which I have connected. You can see here the request is timeout. The goal is when try to this access, it should be NAT to the Windows PC. We'll enable the rule. Then you can see here traffic is passing towards to the destination. We'll see the firewall logs, show matching logs. You can see here source PC is 172.16.1.10, destination 172.16.1.1, and you can see here more details. You can see the NAT IP 10.200.1.1, the destination IP NAT to this IP. Okay, let's go back to the question. As per the question, the same scenario, the issue is the connection is timeout. At the same time, administrator run on sniffer on the FortiGate to capture incoming web traffic and server does not see any output. Okay, let's go back to our lab demo. Now at the moment you can see here the VPC client cannot access the 10.200.1.10. It's giving request timeout. At the same time we'll enable sniffer on the FortiGate side and see what's the output. Diagnose sniffer packet, and the host is our host IP address and ARP. Let's see the output. You can see here already we enable ICMP towards to the 172.16.1.1, but you can see here there is no any log sniffer output on the firewall. Okay, let's go back to the VIP configuration using CLI. Config firewall VIP, then edit your DNAT. DNAT means the virtual IP name. Then you can see here the ARP reply is already disabled. Let's enable the ARP reply. Set ARP reply enable, then end. Okay, let's generate the debug sniffer output again. In the same time I'm initiating the ICMP request towards the host. Now you can see the ARP reply and ARP sniffer details. You can see in the output who has in the port 3 out ARP reply. Okay, let's go back to the question then at the correct answer. Answer A, configure a loopback interface with the IP address 203.10.113.2/32. This is not relevant answer. This one is incorrect. Answer B, in the VIP configuration enable ARP reply. Yes, this one we can select as a correct answer at the moment because we saw that how to enable ARP reply and show the output. Let's go to the answer C. Enable port forwarding on the server to map external service port on the external service port. This is already configured. You can see in the VIP configuration and the firewall policy. This is already configured. So this one, hence the answer C is incorrect. Let's go to the answer D. In the firewall policy configuration, enable match VIP. This is also configured because you can see in the firewall policy DST address. You can see web server -ext. The VIP name is web server.exe. This is already configured. And the answer D also incorrect. So C also incorrect. A also not related. So we can select as the answer B as the correct answer. Okay, let's go to the next question. What are the two functions of CTNA? Choose two. Answer A. CTNA manage access through the client only. Answer B. CTNA manage access for the remote users only. Answer C. CTNA provides security posture check. Answer D. CTNA provides role-based access. Okay. Let's understand what is CTNA or ZTNA. CTNA means Zero Trust Network Access. In FortiGate is security approach that ensures the only authenticated and authorized users and devices can access application and data. Assume that no user or device inside or outside the network should be trusted by default. Every access request is verified. That means grant access to specific application or resources rather than the entire network. This minimizes the risk of the user or device is compromised. It is continuously monitors user and devices activity to detect and respond to any suspicious behavior. Let's understand how CTNA works. When the user and device authentication, before grant access, FortiGate verifies the identity of the user and device using method like multi-factor authentication (MFA). And also policy-based access. Access is granted based on the defined security policies that consider user role, device health and the other factors. When considering the application level access, user get access only the specific application they need rather than broad network access. And the communication are encrypted to protect the data being interrupted. And the floating client is essential for both internal and external users to secure their access to the network resource through CTNA. It is ensure continuous authentication, applies consistent security policies and provide robust endpoint protection. CTNA tags further enhances security by enabling granular dynamic access control. Okay, since this is a new feature, let's understand how to configure CTNA in the FortiGate firewall. When you log into the FortiGate, first you need to come to the system feature visibility. And you can see here Zero Trust Network Access is disabled by default. You have to enable, and when you enable it, you can read the description. Zero Trust Network Access use CTNA tags to provide by FortiClient EMS to control access to internal server under policy and object CTNN firewall policy. Okay, let's apply. When you come to the policy and object section, you can see new feature called CTNA. Okay, there are three tabs you can see here: CTNA rules, CTNA servers and the CTNA tags. So in the first step, you have to have a EMS or FortiSASE server to use this feature. Only with the firewall you cannot use this feature. So when you configuring, first you have to configure the CTNA server first. That means external user access to internal server or something like DNAT. You have to configure this external IP, external port, then you have to map the internal server. Once you map the configuration, you can create the CTNA server rule. In the rule section, you can see here the rule name and the source, CTNA tags. Tags configuration is done with the EMS or FortiSASE. Once you install the Forti client to the PC, then you can select the CTNA server. Then you can apply antivirus profile, application profile in the firewall policy. So you don't need to configure IPsec VPN 40 SSL VPN configuration for this once you enable CTNA. Okay, let's go back to the question and find out the correct answer for this. Answer A, CTNA manage access to the client only. No, this one is incorrect. Answer B, CTNA manage access for remote users only. No, this is remote and internal both users. Answer C, CTNA provides security posture check. Yes, you saw that in the informations. It provides security posture check using CTNA tags as well. Then answer D, CTNA provides role-based access. Okay, yes, this one also correct. You can configure role-based access. For this question, the correct answer is answer C and D. Okay guys, that's all for today. Thank you all for attending today's class at 591 Lab. We hope you found the material informative and helpful. Remember, practice is critical to mastering any new skill. So review the course content and keep practicing with the 591 Lab help and support. If you have any question or concern, please don't hesitate to contact us. We appreciate your participation and look forward to see you in our future classes. Have a great day.